Okay, today we're going to go over the review for the final. Basically what we're going to go through in these two sessions is exactly what the final will look like. In other words, you'll see the same kind of problems on the final. All that will be changed is the numbers that are used in the problems and perhaps the order of the problems. And so when we do a particular problem like this first one, where we're going to be looking at solving the system of equations with a graph, you will have one just like that. It'll just be a different parabola and a different straight line kind of thing than what you see here. So really, outside of you just following along, there's no homework left at this point. Everything should have been turned in. This is just so you know exactly what to focus on for next week's final. So, first off, we want to graph these two lines, or these two curves. In the first case, we have a parabola. You can tell it's a parabola because it's got the x squared term, and over here it's just y. And here we have a straight line because neither the x or the y have any exponents. So let's go ahead and make a t-chart. Of x and y to graph. The important thing to note is that this is already in vertex form. That will be the middle. So opposite of what's inside the parentheses, that will be a 2. Same of what's outside the parentheses, that will be a 15. And so that's our vertex. Also, because it has a negative sign out in front here, it's going to open downward. So if I go to a 3 here, so one more, 3 minus 2, that's 1, 1 squared is 1, minus 1 plus 15 gives me a 14. And since I went 1 to the right, the same has to be true for 1 to the left. That will also be 14. Okay, now we'll go to 4. 4 minus 2 is 2. 2 squared is 4. Negative 4 plus 15 is 11. So 0 will also be 11. And again, just to check, 0 minus 2, well, negative 2 squared is still 4. Negative 4 plus 15, it's back to our 11. Okay, now we have 5. 5 minus 2 is 3. 3 squared, 9. Minus 9 plus 15, that would be 6. Therefore, negative 1 is also 6. Next we go to 6 here. 6 subtract 2 is 4. 4 squared is 16. Negative 16 plus 15 will be a negative 1. And so we have negative 2 will be a negative 1. 7. 7 minus 2 is 5. 5 squared is 25. Negative 25 plus 15 will be negative 10. And so negative 3 is negative 10. 8. Well, 8 minus 2 is 6. 6 squared, 36. Negative 36 plus 15 is negative 21. I've run out of room on top there, but negative 4 will have to be negative 21 as well. So starting with the vertex, which was at 2, 15. So 1, 2, up to 15. 3 was 14. 1 was 14. 0 was 11. 4 was 11. 5 is 6. Negative 1 is 6. Notice that when I'm graphing this, I'm doing them across each other each time just to keep up that symmetry. 6 is negative 1. Negative 2 is negative 1. 7 is negative 10. Negative 3 is negative 10. And the last 2 points would actually be right off the graph. So 8 is negative 21, which would be down here approximately. And negative 4 is negative 21, so again about there. So those ones are just off the graph. So go ahead and connect the dots. And of course this one would go towards that, and over here towards that. And there is the parabola. Okay, now I've also got a straight line. The straight line is in slope-intercept form. The slope is 1. There's nothing in front of the x, so it's a 1. And it starts at 1, so it'll start here. And then its slope will be a 1. Now, it's up 1 and over 1, but honestly, I would put the points slightly far apart. So up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, and so forth. So it's going to go through here, and then down 1, down 1, down 1, back 1, down 1, back 1, and so forth. It's going to go here. So I have some far apart that I can use to line up. And then there is the straight line part. Now, since this is solve the system of equations, that means I need whatever points would simultaneously solve both equations. So that is where the two curves intersect. And so our solutions, in this case, we have a negative 2, negative 1. And up here, we have 5, 6. And so these are the solutions to our problem. Now we know that the negative 2, negative 1, 5, 6 work for the parabola because, of course, here is the 5, 6. Here is the negative 2, negative 1. To see that they also work for the straight line, if I put in a negative 2 plus 1 is a negative 1, so that one works. If I put in a 5 plus 1, that's 6, and so the second one works. And so there is problem 1. And again, you're going to get a problem just like this, two equations in which they're not both straight lines, in which you have to graph and then figure out where they intersect, and that would be your solution to this system of equations. Now, problem 2 here is to graph a circle. I know that it's a circle because I have an x squared plus a y squared. And neither one of them has anything in front. So even if I were to see if this made an ellipse, it would have to have the same number underneath both. And so it's a circle. I need to figure out where the center is. And what the radius is. I also then need to find a total of 8 points. Now 4 of those points will come from the center and the radius, and I need to complete the square twice for this. And then the other 4 points will come from testing one point and figuring out by symmetry where the other points must be. So first off, let's rewrite it so that it's in the right form. X squared, subtract 6x, and then plus y squared plus 8y, and then that's going to equal 24. Okay, completing the square, cut in half, square, add to both sides. So here I'm going to have, in fact, let me go ahead and rewrite it again. Here I'm going to have x squared, subtract 6x. Half of 6 is 3, 3 squared is 9, so I'm going to have a plus 9 there. I'm merely using the parentheses so that you can see everything separated. Half of 8 is 4, 4 squared is 16, so I have to add 16 here. And then I'm going to have 24 plus 9 plus the 16. So this part here gives me x subtract 3 squared. This y plus 4 squared. 29 and 4 and 16 is 49. So now we have the equation for a circle written in center radius form. The center will be the opposite of what's inside the parentheses. So opposite of negative 3 for the x, opposite of the plus 4 for the y. There is our center. This represents r squared, and so r will be 7. So in terms of graphing, again, our center is at 3, negative 4, so 1, 2, 3, down to negative 4. There's the center. Since the radius is 7, I can get 4 points just by going left 7, right 7, up 7, and down 7 from the center. So 1, 2, 7 here. And then 1, 2, 3, 4, 5, 6, 7 that way. So that's the 7 left and right. And then 1, 2, 3, 4, 5, 6, 7 up there. And 7 down here. So here I have the first 4 points, up 7, down 7, left 7, right 7. So that's the first part of making this graph. And then the second part of making the graph is I have to have 4 additional points so that I can trace out the circle. Obviously right now it looks more like a diamond or a square. And no, you can't just kind of fake it around these points. You need to actually show me the work for getting the other 4 points. So you usually want to pick something that's kind of in the middle. So let's let x equal 0 of the equation that we have here. So 0 minus 3 will be negative 3 squared, so that'll be 9 plus y plus 4 squared equals 49. So y plus 4 squared will equal 40 when we subtract 9 from both sides. So y plus 4 equals plus or minus the square root of 40. And you got to say plus or minus, which since we're going to be doing graphing, we can go as plus or minus about 6.3. More than 36, which would be 6, less than 49, which would be 7, so 6.3. So moving the 4 over, we're going to have negative 4 plus or minus 6.3. So that's going to give us, if we subtract them both, y will equal negative 10.3. and y will equal 2.3. Negative 4 plus 6.3. So that gives us 2 points now because these were both for x equals 0. So one of those would be 0, negative 10.3, and the other one would be 0, 2.3. Now, basically, I went 3 to the left for x. In other words, from the center point, which was at 3, I went to 0. So the same thing has to be true by symmetry at x equals 6. Because at x equals 6, I'll have 6 minus 3, which is 3, 3 squared, and I'm back to the 9. And so I also have 6, negative 10.3, and 6, 2.3. And so just by using 1 point, I get one value of x, I get 4 different points that I can now make for my graph. And so let's see, 0, negative 10.3, so that's going to be right in this territory. 0, 2.3, it's about there, not quite halfway. 6, negative 10.3, so again that'll be right in that territory. And then 6 and 2.3, so right about there. Trying to make them so they weren't quite halfway. And so now that I have my points, I can go ahead and start to fill it in. And so a circle, go ahead and just shift it slightly so it's easier to fill in. And so maybe not quite perfect, but close enough. With, again, the 4 points that I got from the center and the radius, and then 4 more points that I got from picking the value of x equals 0. Basically the idea is you just want to pick something that's kind of in between. You know, if I'd gone over maybe to 4, it might have been a little bit better. Obviously if I did even more points, it would be easier to sketch out the circle, but 8 points are required when you graph your circle. And so there is problem 2. All right, now let's look at problem 3. This gets into where, first of all, equations of the line, figuring out equations of the line, figuring out lines that are parallel and perpendicular, all of those things that we did earlier in the semester. Remember that if it's parallel, the slopes have to be the same. If it's perpendicular, you have to have the negative reciprocal of the slope. So I want to find the equation of a line that is parallel to this line here, and so here is our slope. So m equals 2, and this line goes through this point. So we're going to use the point slope equation. Y minus y1 equals m times x minus x1, where the point, the 4, 7, will go into the x1 and y1, and the slope 2 will go there. So y subtract 7 equals 2 times x subtract 4. And then from this point on, it's just a matter of simplifying. So y subtract 7 equals 2x subtract 8, add 7 to both sides, and I'm going to have 2x subtract 1 as my answer. Note that this had a 2x, this has a 2x, so that they are parallel. However, their slope intercepts, the b4 here, -1 there, are different. In the second problem, we're going to do a very similar thing, but this time we're going to use something that's perpendicular. So again, here is my slope, but I want something that is perpendicular to that. So the actual slope I have is 1/3 But for the perpendicular line, I'm going to need an m equal to -3. So, or 3 over 1. So 1/3 became 3 over 1, and positive became negative. And I guess over here I'll say, because it's parallel, same slope. So, perpendicular is this part. And over here we were parallel, just so you can copy down the notes there. So again, we're going to use our y minus y1, m times x minus x1, plug in the numbers, -6, -9. So this is going to be y plus 9 equals -3 times x plus 6. Note, since the values were both negative, -6 and -9, and you're subtracting them in the original equation, they both became pluses in the new equation. So y plus 9 equals -3x, subtract 18. Subtract 9 from both sides, and we have y equals -3x, subtract 27. And so problem 3, parallel and perpendicular, and using the point slope equation to find the equation of the lines that fit the particular information desired. Alright, next in problem 4 we're going to look at problems that have functions, and how we can basically kind of go to a function notation for solving problems. So here I have f of x equals 3x subtract 1, g of x is x squared subtract 1, and h of x is x squared plus 4x plus 5. So in this case, this is kind of a shorthand. Instead of having to write everything out, we have f of g subtract h of 11, and so really what this is going to be is f of 11 plus g of 11 subtract h of 11. It's just a shorthand instead of having to write all of that out. And so I can just simply solve each one separately and then do the add and subtract that I've been asked to do. So f of 11 will be 3 times 11, subtract 1, which is 32. 33 minus 1, that's 32. The g of 11, well, that's going to be 11 squared, subtract 1, which is 120. 11 squared is 121. 121 subtract 1 is 120. H of 11 will be 11 squared plus 4 times 11 plus 5, and that will come out to be 170. So f plus g minus h of 11 will be the 32 plus the 120 subtract the 170. And so f plus g subtract h of 11 equals negative 18. And while not necessarily written out this way, this is similar to what you can do when you're doing a spreadsheet. You've got different cells that have different operations, and then you can combine the cells to give you a final result somewhere else. Alright, part B here, we're going to look at what are called nested functions, nested loops here. We want to work our way backwards. So here we got to do f first. The result of f will go into h, and then we'll use the h function, plug that in, and whatever we get from that will then go into g at the end. So the key is you always start on the inside, work your way out, or if you want, you start with the last letter and work your way backwards. Please note you have to do the letters the way that they're listed, not in alphabetical. So I have to do F, then H, then G in this case. So first off, doing F of 2 will give me 3 times 2, subtract 1, which is 5. Okay, so now the 5 is going to go into H. So now I'm going to do H of 5. So again, whatever I get here has to go into the next function. So now H of 5, and I'm going to get 5 squared plus 4 times 5 plus 5. 25 and 25, that's 50. And so that then has to go into G. So as I mentioned again, whatever we had has to be the input. The output of the previous one has to become the input of the next one. And so now I have 50 squared subtract 1, which is 2500 subtract 1, so 2499. And so there is the other one for problem 4. Working with equations listed in function notation. Alright, problem 5, we want to solve this by making the basis the same. Now, please note, there are several different ways to do this, but when you are actually instructed to do things a certain way, then that's what you have to show in your work. Even if you have the right answer, if you have not shown it the way you're supposed to, then that would be a problem. So, here I have 4. Here I have 32. Now there's no multiple of 4 that, or excuse me, there's no power of 4 that gives me a 32. However, 4, of course, is 2 squared, and 32 is 2 to the 5th, and so I can make both of these into base 2. So for the 4 part, let me go ahead and rewrite out what I've got. 4 to the 6x subtract 3 equals 1 over 32. But that 32, or excuse me, that 1 over 32 can also be seen like that. Remember, that's what a negative exponent does. It means 1 over. So now replacing the 2, I'm going to have 2 squared, and then to the 6x subtract 3. And for the 32, I'm going to have 2 to the 5th to the negative 1. Now, anytime you have exponents in which you have an exponent parenthesis and another exponent, then the rule is multiply. So this will become 2, and that will be 12x subtract 6. And over on this side, you'll have 2 to the negative 5. And so now I have written the original problem in basically with the same base as base 2. Now I can go ahead and solve it. Since the bases are the same, the only way that this can be true is if the exponents are also equal. And so I have 12x subtract 6 equals negative 5. Again, the only way this can be a true statement, that 2 to the 12x subtract 6 equals 2 to the negative 5, since the 2's are equal, 2 and 2, the exponents have to be equal as well. I'm not really doing an operation so much, it's just recognition. That's the only way that that can be. And now solving, 12x equals add 6. So x equals 1/12. And I have solved for x by making the bases the same. Okay, now if there are no instructions exactly, in other words, it doesn't say to do it in a particular way, then you can do it any way you want, as long as you solve the problem. So whereas in problem 5 it said make the basis the same, problem 6 just says solve. So we can go ahead and solve it any way we know how. Well, first off, I have log base 5 and log base 5, so I can put those two together. Log base 5, this is the add rule. And the add rule means we take what was in the two logs and we multiply them. And so now I have just one log. Next, we're going to go from log form to exponent form. So remember that you want to match things up. And so the way this is going to work is we're going to write this part first. That was essentially what we did as an x before. What was the base is still the base, and then that became the exponent. So really what we're looking at is log form is you have log base x equals y. So that's my log form. And then in exponent form it becomes x equals b to the y. So again, it's more a matter of just recognizing the pattern than you're actually doing a particular kind of operation. So the base remained the base, what the log was of became on one side of the equal sign, and what was on the other side of the equal sign became the exponent. Continuing on, now we're going to solve this. So, foiling, 3x times x, 3x squared. Outside, 3x times the -1, -3x. Inside, 2x. And then subtract 2, and that's going to equal 5. Putting it all together, we will have 3x squared, subtract x, subtract 7 equals 0. This is not factorable. I can tell that just because the only thing that's going to work here is the 1 and 7, and there's no way to get back to a -1 in the middle. So let's use the quadratic. We're going to go a is 3, b is -1, and c is -7. So over here we got x equals, remember it's minus b plus or minus b squared minus 4ac all over 2a. So x will equal 1 plus or minus 1 squared minus 4 times a times c, which 4 times 3 times the -7 all over 2 times the 3. Negative here will means add. 4 times 3 is 12. 12 times 7 is 84. 1 and 84 gives me 85. And then it's all over 6. So there is our answer to this problem. Alright, that gate got us through chapter 4. Now we're going to look at some chapter 5 problems, matrices. And again, the first thing to note is that some of these will say to use a particular method, so we have to use that particular method. So first we're going to do the Gauss-Jordan method. The Gauss-Jordan method just means that we need to basically end up with an identity matrix. So first off, we're going to transform the two equations, 3, 2, negative 11, negative 7, 43, and 27. So we have written an expanded matrix in which these parts come from the x and y's, x's, y's, and then these parts come from the coefficients there. And then, as I said, we want to make this part be 1, 1, 0, 0, and that'll tell us what our x and y are. So I need a 1 right here, so let us do negative 1 times row 2 plus row 1 in row 1. So negative 2 plus 3 will give me a 1. Negative times negative 7 will be plus 7, and a negative 11 would be negative 4. Negative 27 and 43 will be 16. So I have changed row 1, but I do not change row 2 at this point. So I have 2, negative 7, and 27 there. Okay, I need a 0 here, so I'm going to do negative 2 times row 1 plus row 2 and put it in row 2. So 1 times negative 2 and 2 will give me that 0 that I was looking for. Now I'm not going to be changing row 1 in this case, so I can go ahead and write it down. So, as I mentioned, that'll be 0. Negative 2 times negative 4 is positive 8. Positive 8 subtract 7 is a 1. And then 16 times negative 2 is negative 32. Negative 32 and 27 would be a negative 5. And so it happens, in this case, I got my 1 there right away just by trying to get the 0 there. Okay, I need a 0 up here, and so I'm going to go 4 times row 2 plus row 1 in row 1. I want to get that 0 up there. So in this case, it's the second row that won't change. 0 times 4 is still 0, so the 1 will remain there. 1 times 4 is 4. 4 and negative 4 will give me a 0. Here, 4 times negative 5 will give me negative 20, and 16 will be negative 4. And so, x equals negative 4, and y equals negative 5. And my solution is negative 4, negative 5. These are two straight lines, and so the solution is the point of intersection between them. So there is problem 7. Okay, this time we want to use Kramer's rule to solve the system of equations. And again, there are many ways to solve these, but we're going to be doing Kramer's rule. And so what we're going to do is set up one determinant based on these 4, and then we're going to set up 2 others in which we replace the x's with these and then the y's with those. So let's first find D. D is going to be a 2 by 2, which is 10, 3, 2, 8. So again, here are the x's, 10 and 3. Here are the y's, 2 and 8. This will equal, it's this times that, so it's 10 times 8, subtract 3 times the 2, it's 80, subtract 6, so that's 74. Now we're going to take the 44 and the 65 and replace the x's. So dx, 44, 65, still have the 2 and the 8. And so here we'll have 44 times 8, subtract 65 times 2, which is 352, subtract 130, which is 222. Okay, now we'll do the dy's, replace the y's. So the 10 and 3 remain, but the 44 and the 65 go there. And so now I have 10 times 65, subtract 3 times the 44, which is 650, subtract 132, which equals 518. Now once I've done those, my x will equal dx over d, which will be 222 over 74, which it turns out is 3. My y will equal dy over d, which is 518 over 74, which it turns out is 7. And so my answer is 3, 7. And I have used the Kramer's rule to solve this. There's problem 8. Okay, problem 9. Evaluate the determinant. Now, the things that we were doing in problem 7, 8 were just 2 by 2s. This is going to be a 3 by 3 that we're doing. So we want to evaluate the following determinant. Don't forget about the plus minus. So plus, minus, plus, minus, plus, plus, minus, minus, plus. Those refer to the signs when we create the minors, the smaller portions of it. So I'm going to go ahead and just go across the top row there. If I had zeros in this, I would want to include the zeros, because then 0 times anything is just 0. But since these are all numbers, I'll just go ahead and start here. So 3 times 1 for the plus 1. In fact, let me go ahead and just do it that way for the 1. And then this will be times 5, 4, 9, and 7. Notice that it involved the 4 numbers that were not in the row or column of the 3. Okay, next we're going to do the 2, but this is now times a negative 1 because of its positional plus, minus, plus. And then this one will have 6, 10, 4, and 7. And then the last one will have a 1 from this one, and then it'll also have a 1 for the plus minus, and then it uses 6, 10, 5, 9. So we've broken the 3 by 3 into 3 minors. Alright, so 3 times 1 would just be 3. Here, going this way, 35, subtract 36, plus, that will give me a negative 2, times 42, subtract 40, and then the last one, I'll have a 1, times 54, subtract 50, so 3 times negative 1, plus negative 2, times 2, plus 1 times 4. Negative 3, negative 4, plus 4, and our final answer is negative 3. And that is problem 9. Alright, the last problem we're going to do for the first part, we want to find the product multiplying two matrices. The basic idea is you take the elements in a row, you multiply by the elements in a column, and that gives you the first element of your product. So let's go ahead and So we're going to have -1 times the 3 plus 2 times the 1 plus 3 times the -1. So note, -1 times the 3, 2 times the 1, 3 times the -1. Okay, and then we can go across, so the next one will be -1 times the 1 plus 2 times the 5 plus 3 times the -3. And so that will be this row times that column gives me this element. And then finally, this first row across the last column, we're going to have -1 times -1 plus 2 times -3 plus 3 times 1. And then that will finish off the top row of our product. Okay, now we'll use the second row times the first column. And so we have 3 times 3 plus -1 times 1 plus 2 times -1. And then we'll have 3 times 1 plus -1 times 5 plus 2 times -3. And then 3 times -1 plus -1 times -3 plus 2 times 1. And so we have finished out row 2. Again, this times that, this times the next one, this times the third one. Okay, our last row, 2 times 3 plus 3 times 1 plus 6 times -1, and then here 2 times 1 plus 3 times 5 plus 6 times -3, and then our last element, 2 times -1 plus 3 times -3 plus 6 times 1. And note the pattern as you're going through this, the second numbers as you go down were always the same. And as you go across, the first numbers are always the same, 2, 2, 2, 3, middle one, 3, 3, and so forth. Alright, so putting all that together, we have -3 plus 2, subtract 3 more, so that's a -4. 9, subtract 1, subtract 2, so that's a 6. 6 plus 3, subtract 6, so that's a 3. -1 plus 10, subtract 9, so that's a 0. 3, subtract 5, subtract 6, -8. 2 plus 15, subtract 18, -1. 1 minus 6 plus 3 is a -2. -3 plus 3 plus 2 is a 2. -2, -9 plus 6 is a -5. And so there is our product. And so we have finished half now of our final.